you know, if I take this is a perfect circle, or you can say it is a disc. It is a disc of radius r and mass. Okay, so if I say omega bar, okay, and if I say cross, so what is your understanding here?
It is inside the.
That means the body is rotating with respect to your clockwise direction. Yes. So the rotations are all clear to you. Okay. And of course, there is a center of mass here. This becomes the center of mass. This will become the center of mass. Okay. Now, if I keep it on a surface, now aram se think. So there are two things. One is the friction, the coefficient of friction here is 0, condition number 1. In condition number 2, this is not equal to 0. Okay. Under these two conditions, what will happen to this body? You think for 1 minute, I just come. Think for 1 minute, don't answer. Did you all think it on? Hello?
Yes, sir.
Hello?
Yes, sir.
Who will tell me? First condition, Us is equal to 0. What happens? What happens?
Sir, if the body is not having any linear velocity, sir, then it will just roll about whatever point it is.
Why did you say it is not having linear velocity?
I said.
See, if it was there, I would have said. If I have written omega bar, I would have also said VC bar.
Yes.
Since I have not told, it is not there. Okay, anyways, I will still take your answer. It is not having linear velocity, or there is no velocity vector associated with the center of mass.
Center of mass. Yes.
Okay, then what happens?
Yes.
Then the body just rotates about that fixed point.
Okay, I will add this. So I say this is the center of mass. So I'll say VC bar is equal to 0. Condition number 1, VC bar is equal to 0. I'll write this condition. Okay. So what happens?
It will just rotate about that point where.
He is telling that the body keeps rotating, and that's it. He says it will be just rotating there only. Do you all agree? Everybody participate?
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
Clear?
Yes.
It will keep
Yes, sir.
rotating. Okay. Now with the same condition, initially, that is, you see here, VC bar at t is equal to 0. I said, is 0. Now here, VC bar at 0 bar. Okay. VC bar at 0 is not equal to 0. So you understand that at time t is equal to 0, VC bar is having some value, and it is not equal to 0.
Yes,
Yes, sir.
And Ms is not equal to 0. Then what happens?
Start rolling. Yes, sir. Yes, sir.
Yes, sir, it is not.
He'll start.
without sleep.
He'll start
So,
rolling.
sir, but it can be by slipping or without
So here mu s is 0 or not? Like
mu s is not equal to 0. That is, mu s has some value.
And even Vc at time 0 is also not equal to 0.
Not equal to 0.
Both are.
Yes, sir. We start rolling, sir. It can be without slipping or with
Sir,
slipping.
it will be with sleeping.
Huh?
Sir, like this friction force, sir, it will act tangentially, sir.
Yeah.
That will increase the angular acceleration of that body which is rolling. Sir. So it will start, the angular velocity will increase of that rolling object, sir. And even that Vc, sir, even that will also like decrease. Sir.
Vc will decrease.
Vc will also decrease.
Vc will decrease.
Yes, sir.
And angular velocity will increase.
Angular velocity will increase.
Angular velocity will increase, Vc will decrease.
Yes, sir.
So this is which case, sir? The
No, no.
function of.
Hey, this is, hey, why are you confusing? Well, I finished this point, now I am with this point.
Okay, yes, sir.
So your friend is telling that, under this circumstance, omega will increase, Vc will decrease. So according to you, if I keep this situation and leave it, then the body's omega will infinitely increase.
Not infinitely.
Correct, that's what, friction is there. So according to you, Vc will decrease and omega. That means, in Tirupati, so after some time, Vc will decrease, become 0, but omega will be increasing like anything.
So until that Vc is there,
Until Vc is there,
that friction will be
friction will be there. If Vc is there.
BC and omega both will be.
Huh. Anybody, come on, all of you think.
Vc will decrease until it will be equal to omega into tangential velocity.
Vc will decrease. So, this, see here,
At that point,
so here you see,
Yes, sir.
it will get adjusted to a position where this body will now have Vc dash, which is equal to omega into r.
Yes, sir. Yes, sir.
Correct? No? Right? And omega dash r. Let me put it like this. So this body will now adjust itself till this condition is reached, and then it keeps rolling forever.
yes,
Yes, sir.
yes, sir.
Clear?
Yes, sir.
Good. So now here we can, okay, there are many ways by which we can analyze. Very nice, very nice answer that is being given here. Okay, because now you see, see, this is the case. Then that is Vc dash is equal to omega dash r is a situation where we say the disk is rolling without slipping. I think all of you know, already I have discussed this. That means now, if the disk is here, this length L, if it is equal to 2 pi r, the disk has moved from this position to this position.
Yes, sir.
Hello?
Yes, sir. Yes,
So, this point has now again back to this point.
Yes, sir.
Got it?
Yes, sir. Yes, sir.
Right? It has moved from position A to position B, it is back. And it has moved a distance 2 pi r. Then we
Yes.
say it has rolled without slipping during that time interval.
Yes, sir.
Yes. Yes,
Clear?
sir.
Now, supposing L is not equal to 2 pi r, right? Then obviously it is
Sleeping.
rolling with slipping. Okay? So now here you see this friction here. Friction here is going to play a role.
Yes, sir.
Okay? Right?
Yes, sir.
So now the thing is, well, now let's consider this case. So what will be the energy of this body? Okay, what will be the energy of this body here? The mass of the body is m, the radius is r, and this is the disk, as I told you. So now you can identify there are two types of energy.
Yes, sir.
One because of linear motion and other one because of the rotational motion.
Yes, yes.
Understand? So linear energy is
Half
kinetic
mvc.
energy half m vc.
Yes, sir.
Yes,
Sir,
sir.
half,
Okay.
half omega. Half
Okay.
omega.
So the kinetic energy of rotation will be half
Inertia.
I omega.
Omega square.
Yes, sir.
And I for a disk, yesterday we have found out it is mr square.
Yes, sir.
So this will be the total kinetic energy.
Yes, sir.
At this point. And there is friction acting here. So what will be the kinetic energy at this point? Will it be equal to this or less than this? Kinetic energy at B, will it be equal to this or less than this?
It will step.
I told without slipping, will L is equal to 2 pi r brother? Again you want to create confusion.
It will not change. It will not
It will be equal. It will be equal.
Sure.
Sir,
Yes, sir.
yes, sir, one doubt.
Yes, please.
Sir, kinetic energy, sir, its total velocity will be tangential velocity plus omega r, sir. It will be something different, no sense.
Wait.
If you consider for individual particles, sir, then Vc plus omega r, vector addition if you do, will get a different velocities.
You will not get different velocity. Why will you get different velocity? See, let me put it like this. Let me put it like this. Okay. Now, this is having omega bar, say into the board, right? And also Vc bar, right? And this is on
Yes.
Now, supposing I create an observer here, who is also moving with Vc.
Yes.
So, from the frame of the reference of observer, what will be the motion of this?
Rotation.
Only rotation.
Pure rotation.
It will be pure rotation. Correct? It will be pure rotation. Correct?
Yes, sir.
Excellent. So, it will be only pure rotation. You see from this. So, now you see, that means now I can split this motion into two types of motion. One is a translatory motion, other one is the rotation motion. Isn't it?
Yes, sir.
Yes.
So you will have, see, translatory means, you see, as a whole the body is moving. The whole mass is moving. So the kinetic energy of this whole mass will be half m Vc square. What is your problem here?
Yes.
See here, gentlemen, see, what is the idea of this center of mass? The entire mass is supposed to be concentrated at the center, and that is moving with Vc bar. So its kinetic energy is half m Vc bar. Vc square.
Yes.
Okay?
Sir,
Yes, please.
now if you consider one individual particle, sir.
No, wait. If you consider also, you take up individual particles and you add up all the energies of that, it will be equal to half mv square, half m Vc square plus half I omega square. It will be equal to that. It will be. So that's how it is. So the observer, you will see only that. Alright. So now all of you are under the contention that the kinetic energy here will be equal to kinetic energy here. Sure?
Yes, sir. Sure.
Yes, sir.
On what basis are you telling that it will be, the energies here and here will be equal? On what basis?
Sir, because the friction does not act.
But just now you told, if friction is zero, then then the body will not move only, it will be rotating there only.
Sir, you said VC was 0 that time.
Yes, sir.
Okay, now supposing I say Vc is not zero. Vc, see, the thing is, please understand, now it was if Vc is not equal to 0, and okay, let me take another case.
Yes,
Huh?
yes.
Let me take another case here. So here there is omega bar also, and there is Vc also.
Yes, yes, sir.
Okay, and mu s is equal to 0.
Yes, sir.
Yes.
Yes, sir.
Okay, then what will happen?
That equation is satisfied.
That equation is satisfied. That is, it is moving also, it is rotating also, and it is moving also. Because this is not going to play any role.
Yes, sir.
Just like how you fire a bullet, it is rotating and moving, it will keep moving. That's it. Correct? But now, if I say mu s is not equal to 0, then what will happen? Yes, as we said, it will get adjusted to such a manner that Vc is equal to omega r, and then it keeps moving.
Rolling. Yes.
It keeps
Yes.
rolling. That's what it is. How it happens, we'll discuss that.
Yes, sir. Yes, sir.
But then the question is, friction, is it not eating any energy?
Initially it leaves.
Then the energy will come down. Will the friction not eat any energy? Is it adding the energy? Is it decreasing the energy? Or it is not either adding or decreasing?
Sir, in pure rolling, it will not consume any energy.
Why?
Sir, because the relative velocity of the point which is in contact with the surface, it is zero. Yes.
So?
So there will be no friction action between the tip of the ball and ground.
Yes, if there is no friction, then it will slip.
Sir, after attempting to... Yes, sir.
No. See, it is because of the friction only it is moving. That is what you only have told now.
Yes.
But the question now is, will the friction increase the energy, decrease the energy, or it will not either decrease or increase the energy? So the question here is that you should say whether friction will do positive work or negative work, or it will not do any work. That if you answer, then rest of the things is answered. So a particular college students, you have done this in detail. Will the friction do positive work, negative work, or it will not do any work? Golden silence. Okay, shall I give you a hint how to answer this question?
Yes, sir. Yes.
Yes, sir. Yes.
Come on, all of you define what is work done. Tell me the concept of work done. Come on, anybody define?
Yes, sir.
Define.
Sir, it is the dot product of the. Oh, sir. No, sir. One second.
Work is said to be done when the point of application of force is displaced in the direction of the force or in any component of the direction of the force.
Any component, Chitrana. So you have by hearted that. You are one good student who remembered, but last chu gaya. Because you didn't understand and absorb that sentence. You absorbed that sentence without understanding.
The component of force if we have a component.
See, listen, I am trying to train all of you. You don't want to get trained. Sir, we were in school like this, we want to be like this. We will not change. You do whatever you want. Then you just go in or now change. See, what I have told, any definition, anything you asked. If you are very sure, you answer. Otherwise, there is a simple way. See, you see the physical situation. Draw the diagram. Okay, when I taught you work done, what are the diagram I draw? So, this was the vector F bar. This was the displacement vector V bar.
Theta.
And this was theta. And this point was P. Remember?
Yes, sir.
And then I said, work is said to be done by this force on the body
Yes, sir.
when the point of application of force displaces, and
Yes.
there is a component of force in the direction of displacement.
Yes, sir. Yes.
Gentlemen, component of force in the direction of displacement, not any component. See, the component of force in this direction will not do any work.
Yes, sir.
See, if you don't see these, that is what I am trying to tell. You must learn science.
Correct.
Understand? If you don't learn science, you see, you cannot do anything in life. See, you might be getting some good marks in these examinations and things like that, etc. But once you become graduates, once you are supposed to design, develop something, you will be nowhere. Understand? Because science, you have to build science in your yourself. Right? Okay. So now, with this concept of work, now tell me, in this case of rolling, okay, here there is friction, and I said MS. MS means coefficient of static friction.
Kinetic friction.
Yes, sir.
So will it do work? See, it will not do work. I'll tell you why. So here you see there is the particle of the body is here and the particle of the ground is here. Understand?
Yes, sir.
Yes, sir.
And the frictional force is acting on both the particles.
Yes.
The frictional force is acting on both the particles. See that frictional force, if you represent it by a vector, the tail of the vector is sitting on both these particles. Hello?
Yes, sir.
Yes, sir.
So can we?
The tail of the frictional vector is sitting on both these particles. So the tail of the frictional force is sitting on the tail of both the particles.
Yes, sir.
So the frictional force, the frictional vector on this particle is in this direction,
Sir.
and the tail is sitting on this particle, and the frictional
Yes.
force on this is sitting like this. The tail is here.
Yes.
Now this tail should displace.
Yes, sir. Sir.
That tail should displace.
Yes, sir.
Then work is done.
Yes, sir.
Yes, sir.
At that moment, the frictional vector is there, but it will be there at that moment, and the next moment t plus delta t, that vector on that particle will vanish, because this particle will move to this position.
Sir.
So that tail of the vector has to displace. The tail of the vector will not, that vector is formed and it will not displace. It will vanish and it will again appear on the next particle.
Yes, sir.
So the tail of the vector had displaced. Then work is done.
Yes, sir.
Yes, sir.
Therefore, the static friction here is not doing work, and that is why you see the body's energy is not changing, because no work is done.
Yes, sir.
Yes, sir.
So this static friction is there only for the body to grip. See, I am able to walk on the road because I am using the friction between my feet and the road as a grip to keep my right leg and lift my left leg and keep it in the center.
Yes,
Same behavior. However, if this is slipping, then there is relative motion between this particle and this particle.
yes, sir.
Then there is friction. Mu k will come into picture.
Yes, sir. Yes, sir.
So if at all work is done, it is done by the kinetic friction,
Yes.
right? And that is why you see now you are riding a bicycle and then cycle, and suddenly you see something, okay? Then you apply brakes, okay? Then what happens? So the braking system in the cycle is that your rotation of the wheel will become zero instantaneously.
Yes, sir.
The rotation of the wheels becomes zero instantaneously,
Yes, sir.
right? But the VC, the translation velocity, will not become zero. So your wheel will now slide on the road. It is called as skidding.
Yes, sir.
So now the kinetic friction mu k will come. So mu k into n is the kinetic. N is the total weight of the person sitting in the cycle. So mu k into n is the force, right? And that force will be acting opposite to the direction of motion, and that is why your cycle will just come to a point.
Yes.
Okay. So it is slipping, then mu k will come. Otherwise, mu s and mu s will not do work.
Yes, sir.
Yes, sir.
Yes, sir. I should.
You understood, all of you? So this is how it is done, and you remember. See, the frictional, the frictional, the static friction is acting in the direction of motion. Hello, you can see here, this vector is in the direction of motion, not in the opposite direction.
Yes, sir.
Yes.
The static friction. Okay, it's not going to do work, and therefore the energy here and the energy there will be same.
Yes, sir.
Is it clear to all of you? Huh?
Yes.
Right.
Yes, sir.
Right. So that's it. We will discuss more of this friction, what it does, how it does, etc., etc. As we proceed.
So
Okay.
If VC is 0 and only omega is there and mu s is not equal to 0, sir, such that this is rotating there, sir. That time also friction is doing not doing work.
Mu s is 0 means what?
Not mu s is not equal to 0, sir.
Mu s is not equal to 0.
But-
Mu s is not equal to 0.
But VC is 0.
VC is
0.
VC is 0, then the wheel is simply rotating. US is not, no, it will not simply rotate. It will roll. It will roll.
Yes.
It will roll. See, the thing is that it will roll. As long as the wheel is not slipping,
Yes, sir.
the total energy is conserved.
Okay, yes, sir.
Yes, sir. Yes.
So, these two quantities will keep changing.
Sir.
Still, they become steady.
Okay.
And
Yes.
that is the condition is that, see, VC plus P equal to omega.
Omega.
Till that condition is there, they will keep changing, but there should be no slippage.
Okay, sir.
That is the whole idea.
Yes, sir.
Got it?
Got
Hello,
it.
everybody there?
Got it.
Yes, sir.
We'll discuss about torque, etc. and all. No? We will understand it. How the torques will come into picture, etc. We'll look into that. Right? Okay. So rolling without friction on stationary surface. See, this is also important. On stationary surface. See, now that it's an indicator for all of you that the surface itself can be moving.
Yes.
Yes.
Yes, sir.
And the wheel can be in motion. So you will have to deal with all the complicated situations. We first discuss velocity relations and thereafter accelerations of 2 points of a body of a round section rolling in stationary surface.
Yes, sir.
Okay. Analytical method. By using relative motion equations, superposition, and by using ICR. So we will handle this with all these things. Okay.
Yes, sir.
So this description is very simple here. Okay. So this is the center. So you can see this arrow here. Look, what does it mean? It is having VC. Right? Velocity of the center can be obtained with the help of the relative motion equations. VC is equal to Vp bar plus omega bar cross PC bar. So that is Vp is what? The absolute velocity of point P.
Yes.
What is this point P? See, please appreciate this. This point P is the point on the circumference of the circle, not the road.
Yes, sir.
Yes, sir. Yes.
Yes, sir.
Right? And as I explained, momentarily this is at rest.
Yes, sir.
And therefore,
Yes.
Vp bar will be equal to 0. And omega bar PC. So, omega bar will be omega k cap cross R bar. So, VC is equal to so and so. So, this condition it is satisfied. Then I said it is rolling without slipping.
Yes.
Yes, sir.
So, from that, we will consider now a particle B, particle A. You can see here XY reference frame is given here, and we go on to proceed.
Yes, sir.
Okay. Now, from this diagram, see we got VC bar is equal to omega R I cap.
Yes, sir. Yes, sir.
What is VA bar equal to?
Both the resultant of VC
Yes.
and omega.
2 omega. Yes.
2 omega. 2.
How is it 2 omega?
Yes, sir.
Omega
P is IC is equal to.
Yes, sir. Into its
Yes.
So this,
Distance is R.
so from here to here it is R, from here to here it is 2R.
And
R.
2R.
So omega into 2R will be the component of, what is omega into 2R?
It is a
Total
velocity of
Total velocity.
and that is
VA bar is
Isn't it?
total velocity.
Total velocity. Because you are taking with respect to this point.
this point, yes, sir.
Yes.
See,
Yes,
this
sir.
velocity at this point, see, please appreciate and understand, the velocity at this point you are considering with respect to this point P.
Yes, sir. Yes, sir.
Yes. Yes. Sir.
So with respect to this point P, and because this line AP, is also rotating with omega.
Yes, sir.
Yes.
So therefore the velocity of this point will be 2 omega into 2r
Omega into 2R.
Yes.
with respect to this. Now if I take now this point C,
Yes, sir.
then if you take this point C here,
Yes. Sir.
okay, then what is the velocity of this point A?
Relative velocity. Omega.
Velocity of A, see listen, velocity of A, absolute velocity of A, hey,
Yes, sir.
I know say that. Velocity of absolute velocity of A with respect to C.
Omega.
Yes, sir. 2 omega and this omega. 2 omega.
It will only be omega r.
Yes, sir.
Omega into r with respect to c, I am telling you, with respect to c means
Yes.
you have stopped c
Yes, sir.
and you are putting it.
Yes,
So
sir.
with respect to c it is omega r, with respect to p it is 2 omega r.
Yes, sir.
2 omega.
Right?
Yes, sir.
So I suppose you got it. So now that means now all the points on this slide. Okay, this is omega r. So all the points on this slide, you know, their velocity, the absolute velocities will start decreasing. Correct?
Yes, sir.
Yes, sir.
Anyway, I not
Yes, sir.
Yes.
simply drag it there.
Yes, sir.
Okay. So what I wanted to say something is like this quickly. So now if you draw this line, see this is the line, this is P and this is the point A and this is C. So with respect to this point, if I say this is how much? 2 omega r and this is 0.
Yes.
Okay. So this vector is omega.
Omega.
So you can now say what are the velocities of this.
Yes.
Understood?
Yes.
Yes.
So it will
Yes.
keep decreasing. As you go.
Yes, sir.
Yes.
Okay? Good. And mathematical modeling also. The above equation is used as a condition of rolling. This is used as a condition of rolling without slipping or stationary surface. Velocity of the top point P can be obtained by relative motion equation. Okay, VA bar is equal to VP plus so itself 2 omega. We just now did this. Once velocity of the center is obtained, we can use relative motion between A and C as well. So VA bar is equal to VC plus omega so and so. So VC is equal to omega RI plus so and so. So VA bar will be equal to 2 omega bar I is equal to 2 VC bar. We just now saw. In similar fashion, velocity vector of any arbitrarily chosen point B. Arbitrarily chosen point B. Okay. So here you see, with respect to C, what is the velocity of this point B with respect to C? So with respect to C, it will be omega into R. RB.
RB.
Yes.
R suffix B it is. R suffix B. Okay. That vector will be perpendicular.
Perpendicular. Yes, sir.
Understand? That is with respect to C.
Yes, sir.
Yes, sir.
With respect to ground, what is the absolute velocity of this?
Plus the velocity of
Sir, RB.
Yes, sir.
So-
Plus the velocity. VB bar plus VCM.
Yes. No, not just listen.
Omega into RB sin theta plus R sin theta.
So here, with respect to this point, you will get this velocity.
Yes, sir.
Correct? And this will be what? Omega into RB.
RB.
Yes.
Now, if you say, now that is, I said that this is notionally at rest.
Yes, sir.
Now, if you say this is going to move with VC,
Yes.
then you have to add this to this.
Yes, yes.
Understood? You have to add this. So, this vectorial addition will be the absolute velocity of vector B.
Yes.
Okay, I suppose. So, everywhere, you know, this is going to be the condition.
Yes, sir.
Okay? So, VB bar will be VC bar plus omega CB. So, VC I cap minus omega K cap cross CB will be R cos theta I, R sin theta I. I hope, suppose you understood.
Yes, sir. Split into
Yes,
Split it into two components. So, you will get here VB is equal to VC plus omega R sin theta I cap. So, theta, what is the theta that you have taken? This is the theta.
So minus.
Okay, so X component will be minus.
Yes, sir.
Minus cos theta.
Minus cos
VC minus
theta. Cos theta.
Cos theta.
Okay.
So VB bar will be omega R sin theta. Omega r sin theta.
Should cos.
It should be cos theta, no?
Sir, show one more time.
This theta. So this will be r cos theta will be in this direction, no?
Sir, no, sir, it will be sin theta only, sir.
Right?
That angle you are taking, sir. Omega r will be perpendicular to that, sir. That alternate angles and you use this, sir, then you get it has sin theta component will belong x.
Okay.
Sir, ಒಮ್ಮೆ ಅದು ಯೂಸ್ ಮಾಡಿ ಸರ್ ಹಿಂಗೆ alternate angle ಅದು ಯೂಸ್ ಮಾಡ್ತೀವಲ್ಲ ಸರ್
alternate angle
90 minus theta ಬರ್ತದೆ ಸರ್ so the angle between x axis and the omega axis
this correct, you are right.
Yes, so you get that
Yeah. So this is theta, so this will also be theta,
yes yes
and this angle will be 90 minus
90 minus theta.
Yes. Okay. Then we take cos. So this vector
Into
cos of 90 minus theta will be sin theta.
Thank you, yes, sir.
Yes, sir.
So therefore this will be sin theta. So you will get here VC bar is like this, and this one will be the VA sin theta. Okay, will be in this direction, isn't it? VA sin theta will be in this direction. Correct.
Yes.
VS
Yes.
No, sorry, plus only. Because this it will be in the same direction. Sorry, it will be in the same
omega
direction.
sin theta.
It will be in the same direction. VA sin theta will be in the same direction. Both will act.
Omega sin theta.
Omega.
Omega.
Yes, omega r sin theta plus VC.
Plus yes.
Okay, thank you.
Yes, sir. Yes. Yes.
Good. Is it?
Yes.
Yes. So I think it is omega r sin theta I cap plus this.
Yes.
Okay. Thank you. So velocity relation by superposition method. I think in this process we discussed this also.
Yes.
Yes.
You also discussed this.
Yes, sir. Yes, sir.
Your rotation about the center.
Yes.
Right? Then
Yes.
velocity at arbitrary point B will be this is theta, and then this is VB bar,
Yes, sir.
okay, and this is VC
Yes.
bar, okay, and this is omega. You can see this line here,
Yes, sir.
Yes, sir.
omega r, they are shown here. This is omega r, VC bar, and so VB bar. Very simple.
Yes, sir.
Yes.
So this also good. Okay?
Yes.
Now velocity relation using ICR. Right? Okay. So instantaneous center of rotation. Okay. In rolling without, I hope all of you understood all this.
Yes, sir.
Right?
Yes. Yes.
If anybody is
sir.
having any doubt, you can ask.
Yes,
Right?
yes.
Aram se, be calm and cool. Okay? See, now you see, if you learn to concentrate, and all these things will look very simple. But in between, if you are losing concentration, then the next step you will not understand, then everything will look so humongous to everyone. So, please, control yourself, just focus. In this age, it is very difficult to control, but you have to control. Yeah. See, these 2 years are very critical. Okay, that's it. So, your brain, your mindset, your body, everything will get set to to become the right professionals. It will ensure that your graduation, your mind and body is ready to learn anything and sustain any amount of pressure. And still, you will be concentrating in spite of pressures. Okay, so therefore, you see, it's a wonderful time. So just keep pegged and just enjoy learning all this. And remember, you have learned so many things. Just imagine, few months ago, you didn't know anything about this. Now you know so many things. And more importantly, you are able to understand all this. That itself is a testimony in itself that there is a lot of things that has happened within you. Your brain power has increased tremendously. In rolling without slipping or stationary, the point of contact is instantaneous rest. So now we are using the concept here that this point is at instantaneous rest.
Yes.
Therefore, the ICR and IER passes through this.
Yes.
We see how velocity at the center, see the top point and arbitrarily choosing this one. So you can see that if you draw lines from here to any particle, that is from point P you draw a line here, from point P you draw a line here, all of them become see now a line from P to B becomes a line connecting the particle P with point P, particle P.
Yes.
Lines from here, this particle to this. And all these lines are going with same omega.
Same. Yes, sir.
Yes. Yes.
Yes.
All these lines are going to move with same omega. And if you multiply it by the distance from this, it will give you a value. It will give you a value. And that value you draw a line perpendicular and arrowhead, and it should be proportional to omega.
Yes.
You get the absolute velocity of any point on this body which is in rolling. It is rolling. Life is so simple. With respect to this, yes, you are going to get absolute velocity.
Yes, sir.
Correct. Because why? Because I'll tell you, you are defining this VC with respect to this.
Sir.
Yes.
This, see, the thing is, you are going to define VC
With the extrude, sir.
having known omega,
Yes, sir. Yes.
Yes.
and therefore VC is not given.
Yes, sir.
You find out VC is equal to omega
Yes.
from
Yes.
this. Okay, so that is why, with respect to this, you are defining this. You are absolutely correct. Okay, this is not given. This you are going to get this value because you only know omega. You only know omega, you get it. Yes, so the equations are clear. So VC bar is equal to omega bar cross PC bar. VA bar is equal to omega PR to omega. VB bar is equal to VC omega r sin theta cos theta. Only thing is you should know that we are marking this angle as theta. Okay, that's important. Okay, so it is 8:25. So would you like to solve this problem?
Yes, sir.
Yes,
Yes.
please solve. Please solve.
Yes.
You are more than happy to solve. Please solve.
Sir, point A, where is it?
50, sir.
Point A is this, man, VA.
Sir.
Okay, same diagrams.
Same?
No, sir, in that question, sir.
Same. This point A. This
Yes.
P.
Sir.
Huh?
50.
But can it?
50
Yes, everybody solve. A cylinder of radius 5 meters rolls on a horizontal cylinder. The velocity of its center is 25. Find the angular velocity and velocity of point. Very simple.
Yes, sir.
So omega into r is 25.
25, sir.
So
Yes.
this one. So omega will be equal to 5.
Yes.
Angular velocity 5 radians per second, and velocity of point A will be 50 meters per second.
50 meters. Yes.
Yes.
Everybody got?
Yes, sir.
Yes.
Nice.
Yes.
So we'll call it as a day. Call it a day today.
Okay.
Yes, sir.
Yes, sir.
Right.
3 hours.
Okay.